Protein. Protein's a big one. So let's take a look. What is protein? Why do we need it? How much do you need? We're going to talk a little bit about these things called BCAAs. Anybody ever heard of BCAAs? Branched chain amino acids? Excellent. All right. So what is a protein? Protein is basically made up of carbon, hydrogen, and what makes protein special, it has nitrogen in it. Okay, it's what's unique about protein with regard to the macronutrients. And basically all it is chains of amino acids, and these are just all linked together. Right? And once a protein gets made in terms of a chain, it's got to go through 3 different folds for it to work. And it's pretty amazing that your body does all this stuff. We were doing great here. Okay. So what's an amino acid? Amino acid falls into basically 2 categories. There's something called non-essential, and there's something called essential. Non-essential amino acids, our body can make those from other parts of the essential amino acids. It's amazing. Our body's like a factory. It can break all kinds of things down, break everything down into basic components of carbon, hydrogen, oxygen, reassemble and make what it needs. Okay, the essential ones, we have to make them, we have to eat them, our body cannot make them. Okay, there's 21 amino acids in total, 9 of them are essential, 11 are non-essential. You know that adds up to 20, there's no one in there somewhere. There's 3 ones that are what we call conditionally essential, and they can be essential in terms of times of stress. When we talk about stress in terms of our society, usually stress is injury. You know, post-surgery, post-major injuries, trying to recover during sickness, they become what's called conditionally essential. So if we look at an amino acid, and this, you're going to have to give me a minute to geek out here because this stuff makes me interested. So the average protein is 500 amino acids long, okay? Just all linked one together, one right after the other. A 4 amino acid chain, a protein with only 4 amino acids, has 160,000 potential combinations. And our body makes ones that are 500. Our body makes ones that are 2,000 long, okay? And your body does this thousands and thousands of times per second, all day long with perfect accuracy. Because after it assembles this chain, it's got to be folded once into its primary structure, it's got to be folded twice into its secondary structure, and it's got to be folded a 3rd time into what's called its quaternary structure. And all that has to happen exactly perfectly for a protein to work. Now what does a protein do? So first of all, we eat it because it helps preserve lean body mass. And that's where everybody first thinks about. They think about, why do we need protein? Well, it's for our muscles. But actually, that's a very, very small percentage of what protein actually does in our body. Okay? It enables our body functions, and it keeps us full. And again, we talked about the thermic effect. So it's a way to keep your body, your stomach full, and reduce your energy intake. So what does protein actually do in our bodies? So it's our #1 structural component. Okay, everybody's heard about collagen. Well, that's what protein is. Collagen is the #1 structural protein in our body. We can see that over here, we see what young, healthy-looking skin looks. And as we begin to age, we do a number of factors, we begin to break down this collagen. That's part of the aging process that damages the quality of our skin. Okay? These are the big ones though, enzymes and hormones. Remember that metabolic pathway we saw? Every little arrow is an enzyme, allowing this product to become this product. And that's where most of the protein you eat. Most of the protein that you digest never makes it out of your liver. Your liver actually catabolizes it all and makes all these enzymes. Makes neurotransmitters. That's how our nervous system works. Everybody ever heard of the neurotransmitter serotonin? Associated with issues of depression, serotonin, norepinephrine, and dopamine. Those are your real big mood ones. They're all made from protein. Okay, amino acids just all reassembled and put back together. Antibodies, our immune system, are all proteins. Okay? They're all amino acids that have been broken down and reassembled by our body to do all the things we need them to do. You talk about satiety. These are your hunger signals. The longer you feel full, the less likely you're going to want to eat or going to need to eat. Okay? Because they're slower digesting. It takes a lot of work to break down the protein. It increases glucagon release. If anybody remembers, glucagon is one of the exit hormones. Okay? It works in exact opposition to insulin. And glucagon is going to help release fat available for storage. It's going to take that glycerol, that triglyceride, break off those fatty acids, and now they can be used for energy inside the body. Well, how much do we need? The recommended daily allowance, or RDA, is 0.8 grams per kilogram. So somebody at 100 kilograms, which is about 220 pounds, is going to need 80 grams of protein. Not a lot. Keep in mind that the RDA is the bare minimum. That's the amount that's required to prevent issues of malnutrition. It's not optimal. Those are two very, very different numbers. Okay? Protein is going to be based on your activity level, and we got to consume it daily because we don't store it well. Yes, we store it in our muscle, and yes, we can break down our muscle, and your body will break down your muscle to go after it if it needs it. Because remember, everything outside of your brain is simply to keep your brain alive. Okay? But it doesn't want to. So, some people talk about protein. Can we eat too much? Well, first of all, yes, from an energy perspective, 100%. You can eat too much. Anything left over that's beyond what you need is going to be converted into fatty acids, which will be stored as fat. Okay? But people hear that when people are on kidney disease or liver disease, doctors will reduce their protein intake. Absolutely. And so that begins to get people saying, well, if I eat too much protein, is it going to damage my kidneys? Well, the answer is no. Okay? Healthy kidneys can handle protein intake. When you look at the research, up to and above 2.8 grams. So again, if we go back to that 100 kilogram person, that's 280 grams of protein. A chicken breast, an average chicken breast has about 20. So if you want to go and eat, what's that? That's a lot of 14 chicken breasts a day. You'll be okay. Maybe we're going to see another issue we got to deal with, but you'll be okay. Where the issue and the analogy that I use with regards to protein and kidney health is, if you break your leg, your doctor can say don't run on it. I'm sure everybody can appreciate that. But running is not going to break your leg. So if you have damaged kidneys and you've got about 10-15% of renal function left, they're probably going to say, you know what, you need to decrease your protein intake. But eating a lot of protein isn't going to damage your kidneys. Right? It'd be very difficult to consume enough protein to actually cause any problems. Okay? Animal versus plant protein. You're going to hear some people talk, they're going to say, oh, you can't eat just plant protein because it's incomplete protein. Yeah, that's a bit of a stretch. They are right in some sense in that plants don't have all the amino acids, but it's not as difficult as people would like to have you believe. As long as you eat a wide variety of plant sources of protein, you're going to cover all your amino acid bases. Okay? And diets high in plant-based protein have been shown to have favorable health outcomes. That's not exclusive plant protein. Okay? My personal belief and my bias, there's a lot of good things with meat. And we can get into talking about meat and processing and hormone raising and all that other stuff. But in general, meat is positive, okay, from a protein source. The nice thing about eating meat is the animals have already assembled all the amino acids for you. So you are getting complete proteins. But you're not in a massive deficit if you eat vegetarian or vegan, as long as you're eating a variety. And that's going to be a common theme, okay? Variety is super important when it comes to nutrition. All right, so BCAAs. And what these stand for are branched chain amino acids. These are 3 special amino acids, and they deserve a little bit of special attention, okay? They are leucine, isoleucine, and valine. I know that was super important, and everybody can rest now that they know that. BCAAs comprise 1/3 of the muscle volume. Of your muscle tissue volume, 1/3 of it is BCAAs. Okay? They're also the only amino acid that's not processed by the liver. So when you consume BCAAs in the form of a drink or mixed with whatever gets broken down during the day, they actually go right from your stomach directly into your bloodstream. Everything else has to go from your stomach to be processed by your liver and then make it out into your bloodstream. So this is one of the reasons why they're associated with exercise, and they're associated with intra or post workout nutrition, which we'll talk a little bit about at the end. Okay, so what do? They can be burned for energy. So if you're consuming them while you're working out, they can help increase the intensity of your exercise because you've got more energy. And remember, intensity of exercise is the biggest predictor of rate of adaptation to exercise. And that's what we're doing by exercise. We're trying to cause our body to adapt. And intensity is going to be the fastest way. The higher the intensity, the faster you're going to adapt to whatever it is you're trying to do. They lower the lactate levels after training. Everybody's heard about lactic acid and how it doesn't feel so good. it's going to actually lower that. It's going to help to buffer some of that acid. So it helps with your recovery. Okay, it increases growth hormone release. Okay, and remember, growth hormone is one of our exit hormones. It's one of the things that's going to help get fat out of the fat storage into the free fatty acid form, so now we can burn it. It's going to decrease your waste products after exercise, again improving your recovery, and it's a key role in protein synthesis. We need it inside our muscles. It triggers, or it starts out, initiates the very complex process of rebuilding muscle tissue. Because when we exercise and we lift weights and we weight train, we basically break down the muscle tissue. And it's when we repair it, post-exercise, that's where we get muscle growth. Okay, and remember, growing a little bit of muscle, getting a little bit more bigger muscle is going to increase your metabolic rate. It's going to increase the amount of calories that you burn on a daily basis. All right?